Hello everyone. Welcome to SAS Explore 2022. Yeah, I am Vishwajit Das, uh, going to present one of the topic regarding improve our forecast accuracy by leveraging some advanced time series techniques, utilizing SAS as one of the platform for analytics tools. So, mm, uh, Before moving ahead on that, I like to give an introduction myself. Who am I? I'm working as basically a senior data scientist in Coke Industries, which is basically have a lot of subsidiaries. So Georgia Pacific is one of the subsidiaries for which I'm working for. So I have completed my MBA in marketing there from KIIT University in India. Then I am currently working as senior data scientist in Coke. Prior to that, I was working as lead data scientist in Tech Mahindra, and also I have experience as an assistant manager analytics in Concentrix. All my experience all are in India itself. So if you look into my domain and specializations, I am I have more experience in marketing and supply chain analytics, domains like telecom, manufacturing, airlines, and e-commerce industry. And currently, since I am working in Coke, so my experience are more into manufacturing domain. So that's my bit of my introduction. So before moving that to the let moves to our today's topic, I'll give you an overview what we'll be covering today in this 30 minute session. So if you look for the today's agenda, so I'll giving you a glimpse of our company, our total group. Then I'll be deep diving into the products where we have utilized this analytics and how we have leveraged SAS by platform for utilizing of more accurate forecast. Then I will give you a glimpse of what is regarding the product which I have built on the whole solution. So that is basically on Lumber market, and then I'll give you on what is the objective and how basically the whole process works, and how the Lumber grading happens in a mill. Then I'll click on what is an auto grader. Then I'll share you how that has been utilized in our platform, and how the outputs has been shared to the stakeholders who are basically needing on this particular output from our analytics solution. So that's all in my agenda. So let's start with the first slide regarding our company. So over here, if you see, Coke Industries is one of the largest private sector in the world. So if you see, we have bunch of companies who work for various domains. So currently, like Molex, GP, Georgia Pacific, Garden Industries, they are dealing with glass manufacturing. Fairfield Resources are basically into resource optimizations, pipelines. Then Infor, we basically provide business cloud solutions to the businesses where they can work with. Invest are basically we are dealing with fabrics, carpets, and the pillow in which you have fiber inside that. So we build over there. Molex, if you see Molex, we are from cars, we are from robotics, all over, even in your phones, even your smart cars, we are all there. So Monex is manufacturing all the semiconductors for that. Apart from that, if you see on the extreme left hand side of the slide, these are the fields, and these are the industry where actually the Coke has the presence, be it agriculture, be it glass, automotive, and renewable energy. If you see Coke as a company, basically we have some around 1,20,000 employees, and we're operating in some around 70 plus location all over the globe. And some around we have employed 60,000 plus employees in US. And we as a company basically builds and have an principle of investing 90% of our earnings, which we and giving back to the society. So we believe in investing the 90% of our earnings. And if you see, since we are morely motivated and also believe in to invest more on technology for front, where we see the investment in technology is some around 35 billion, which makes us as a future ready company and the future ready for any challenges we can face. So that's regarding Coke. So I'll be moving to the next slide where I'll be explaining what is Georgia Pacific. So Georgia Pacific is one of the subsidiary for the Coke Industries. We are been located in 180 plus location. Currently, we're employing some around 30,000 plus employees. As our group, we are also investing 90% of our earnings. Similarly, you can see we have invested some around 9.4 billion till from 2030 onwards, and also we do the community investment regarding education as a CSR initiative. Like we believe in providing enrichment to the environment, and also believe in entrepreneurship principles for each and every employees. So let's move to the products which we have and which we offer. So if you see Georgia Pacific, basically you can see you can involve Georgia Pacific from every walks of the life, starting from, you can say, from your toilet to your restaurant and dispensers, even if building your own houses. So if you see those products which we are having, we have building products, like you might be receiving some cardboard boxes from your local stores or from vendors like e-commerce vendors, where we act as an packaging supplier for them, where we manufacture container boxes, corrugated boxes for that. And other products involves like tissue papers, where you can see, you can if you are in US or some other location in the world, you might have used all these products, like Dixie, Angelsoft, or Brownie. So these are the products which we manufacture. And also we have presence in cellulose also, where we basically deals with paper and pulp. But in this presentation, for apart from all these products, I will be basically focusing my presentation on one of the product called Lumber. If you see Lumber over here, so Lumber is basically being utilized in various sectors, building your own houses and other stuffs also. So let's deep dive into lumber as a products, and I'll explain how the lumber market looks like. So if you see, this is basically regarding the lumber price market. So this slide will give you a glimpse regarding what happens in the lumber market in the COVID times, and what was the average price uh, pre-COVID times. If you see, lumber price actually has a 250% increase from the earlier price. So earlier it was some around $427 per MBF. And if you see, if you compare the May 2021 price, the lumber price has rose to some around 1494, that is $1,494. So that is some around huge, the 250% increase if you compare the lumber price. On this increase is uh, if you compare the history of the lumber price, it is way ahead, and it has crossed all the barriers in the histories. Even if in case of structural panels also, we have a 300% increase. So earlier it has some around $414. Right now it has been moved to some around $1657. So if you see the graph in the extreme left hand side, the graph basically shows how the lumber prices across the timeline for the last 5 years. And if you can see, there is a huge change in the trend of the lumber price. So since we are dealing with lumber and we are basically dealing with the prices of the lumber, so forecasting that particular piece, if you say that if there is a sudden and huge change in the prices, the forecasting that particular piece is how difficult it will be in the real world case. So there might be everybody might be thinking why there is a sudden increase in the lumber price. So that are the I'll basically tell you what are the factors basically leading to this lumber price. So if you see this particular slide which I have showcased, the factors basically leading to the rise in the lumber price over that time. So if you see, uh, in the COVID times, people who are there in their homes, they're basically in the lockdown phase, right? So in the lockdown phase, people doesn't invest in any other things, so they are staying at home. So there are other factors which are basically leading to the increase in discretionary income for each and every people. So people, rather than spending on impulse purchases or any other items, they're thinking of uh, investing in such way so that they can be future proof. That means they can invest for their own future. So they try to start investing or in their household things like buying a house, or if somebody has land, they are constructing their own houses or remodifying their houses. So in that case, if you can see, the housing demand has increased a lot. So if you see in the top left hand side corner of the graph, you can the blue are basically showing the how the house demands increased in a trend line since 2010 onwards. And the supply in that, since we have never seen that much of demand of houses or building products. So the supply is not in that perspective, in that trend. So we have a limited supply since most of the factories are shut down. People are not going to the mills due to COVID. So for functioning a factory was quite an hectic task, and and the supply was a constraint. And due to, since as the demand is increasing and the supply is that we have limited supply, the prices has for the lumber product shoot up. And that is where the main cause for the rise in the prices of lumber. And if you see the graph of the population, this is all regarding the US market I'm speaking up right now. And if you see the population of US since 2010, it has increasing trend. So definitely it will be having an increasing trend. And since the number of people are increasing in a city, we'll be having a huge demand for that. If you say, is this the only factor for which the lumber prices have skyrocketed? I'll not say that is the only one, since we have low interest rate at that point of time also. So if you see the graph in the extreme left, no, below this one, that's the top bottom one in the extreme left bottom. So if you see, this is the interest rates graph. So this is basically the graph for 15-year and the 5-year fixed, basically the mortgage rate since 2000. So if you see, the mortgage rate has drastically come down. And in that period also, US government has given us a stimuli to each and every citizen of US, so that they in that COVID time they can they'll not be having a financial burden over their self. So that leads to an additional income source for the people to invest in that particular perspective. Since we have a low interest rate, people start getting loans easier at that point of time. They thought of investing in a future investment where they can get maximum benefit for their future. So that this all leads to the in more and more demand for the housing and lumber products. Similarly, if you see, since the cost of manufacturing and transportation also increased at that point of time, and since the most of the mills are in the shutdown conditions, we are having also a decreased lumber inventory, and these all factors basically leads to a high lumber price market at that point of time, and the lumber prices have skyrocketed. So based upon all these factors, since we are Georgia Pacific, our day-to-day business in happens in lumber, and we have some around more than more than 10 mills we are having for all this, for manufacturing lumber. So we basically face this kind of issue, and we just need to find out how basically we can forecast accurately to meet the demand in future and even in that particular time also. So that was all regarding the lumber market. So what I'll right now going to do, so this particular example which I'm going to present over here is regarding forecasting of conditional probability of getting a particular lumber. So that means if you see what I'll explain this slide. In this case, like if you say a raw lumber is nothing but a raw timber you get from the forest, and for making that market ready, it should be processed, and for the in the process we basically do a grading of lumber based upon its of the lumber and the structural soundness factor, which basically helps to grade that lumber. So I'll explain what grading is. So grading is basically a process of assigning a quality measurement for a particular raw timber to a finished lumber and giving them a dollar value for that. And if you see, you might be thinking this is normally a you can say a simple job for each and every, but it is not a simple job for grading a particular raw timber into various grades. So that involves a lot of processes, and it is definitely complex and critical thinking, where we need production speeds also to achieve that particular grade. So I'll explain what grading is. So if you see in case of grading, so I'll explain what happens in a lumber mill. So in a lumber mill, actually you have and raw lumber. It is being fed to a particular machine, where machine basically find out what kind of grade a particular lumber can be based upon certain characteristics. So we called it that machine we called it auto grader. So if you see in this particular flow chart, we have an actual input of MBF. That means where the raw lumber is basically being fed to this particular machine. The picture over here in the extreme right shows you the auto grader machine, where actually the lumber is being fed, and the grade is being defined based upon the quality of the lumber, the prices of each and every lumber in the market, and also the rules are being for that particular mills. Like certain mills will produce certain sizes of lumber. That means it can be of certain width, certain thickness, and certain length. That means actually, I'll explain that in the next slide. What basically happens. So if you see this particular slide, in this is input lumber is looking like this, right? So if you feed this particular lumber, the lumber in the top or the photo in the top slide where input lumber is basically written, if you feed that into the machine, so what basically this machine will do, this machine will basically find out the defects in that, the quality of the lumber based upon six sensor it is having over there, like color cameras, black and white cameras, line lasers, dot or grid lasers, and X-ray. So what it basically does, it find out is there any manufacture hole, or is the lumber is being crushed, or do we have a blonde cut or red cut over there. So the if you see after scanning, this particular machine basically wherever it finds any defects, basically marks this as like wherever in that particular part of the lumber it is. Then based upon these characteristics, it basically grade the lumber. So Lumber can be graded based upon like grade 1, grade 2, or grade 1, 2 prime. So these are the grades I'm giving in, like these are the examples of the grades of the lumber. So in this case, if you see this particular slide, I was just explaining, right? So this regarding this conditional probability of mix. Conditional probability of mix is nothing but finding out exact combination of input and output lumber based upon a particular dimensions, and so that if you feed like over here, if you I'm giving an example over here, if I'm going to feed a lumber of a dimension of 2 by 4 by 10, so what can be my output and how much will be my output for 2 by 4 by 8 grade 1 is the lumber grade. Our dimension is 2 by 4 by 8 and grade 1. So let's say if my input lumber is 1 lakh PF, and if I'm getting an output product of 2 by 4 by 8 grade 1 having 8500 BF, so my CP will be 8500 divided by 1 lakh PF. So that will be coming around some around 8.5%. So this is the conditional probability of getting that particular combination of uh, output product from that particular input product. So why we called it conditional probability? Because finding out that particular combination from a particular input product combination and getting that probability. So since the probability having a particular condition, that means we have a condition that we have a particular input lumber and we are getting these are the output lumbers from that particular input lumber. So that for that, that is the reason we are calling it as conditional probabilities, which denote percentage of output lumber produced from the total board feet of the input lumber. So our objective over here is to find out and predict for a particular day or for a particular week, what is the conditional probability of that particular combination of lumber, and how can we more accurately predict that for this particular week autograder will be giving this much quantity of output lumber, and we just need to find improve the accuracy of the forecast based upon this. So that was our objective. So if you see over here, mm, uh, we are having basically some around as I said, some around more than 10 mills in Georgia Pacific. But once we start doing this particular analysis, we have basically done it for one of our mill. And earlier, the process over here was basically the followed by our operation team. They are basically predicting the CP or the conditional probability based upon 3 weeks moving average. And if you see the table in the extreme left, this is basically the result for one of the mill where we uh, just tested our model before moving that into production, and these are the results where our the data science model has outperformed regarding the original 3 weeks moving average which the operation team was doing earlier. So since the operation team over here was basically concerned regarding how to improve the accuracy of the forecast regarding autograder and how to minimize the wastage of the lumber. So that was the ask from the operation team. And since in from the past they are doing on 3 weeks average, so they want a better forecast model where they can improve the current accuracy what they are getting, and in the same time they can reduce the wastages which can be derived from the cutting of the raw lumber. That means how effectively the raw lumber can be uh, cut into various sizes so that we have minimum wastage and maximum ROI from a particular raw lumber. So if you see this particular table, you can see from the out of the 13 weeks we have outperformed each and every weeks, and we have some around 9% improvement from the base, and some around 6% improvement, close to 5 to 6% improvement from the Thieves average. So in this case, that was a huge gain from the in case of operation prosthetics, since in this case, mm, and all the metrics are being weighted on case of footage of the lumbar. Even if 1 to 2% improvement is a huge improvement in case of volume of the lumbar, and they are expecting that at least we should be more than 1 or 2%, or if we are achieving 5 or 6% more, then that will be great. So by utilizing this particular solution from SAS and utilizing the techniques, the new techniques of forecasting, and we have utilized proc ts model, which is being in the SAS Viya platform, which is being one of the metrics or one of the techniques which we have utilized. And apart from that, we have utilized proc anima also over here to achieve this much of improvement. So and this is actually for one of the test mill which we have done. And once this was successful, and then we started exploring in other mills also. So where the output was also better than this in case of other mills. If you see the output of the in the next slide, so here I have given the output results for other mills also. So currently, if you can see, there are the 6 mills output. I have just given it over here. If you see meal number 1 in the top left hand side corner of this particular slide, the first graph you can see over here. So we have some around 6% improvement from the 3x average, and if you compare, we have some around more than 12% improvement from the base. And 12% improvement from the base is a huge improvement in case of operation positives. And since this has been replicated to other mills as such. And similarly, we have in meal 2 we having some around close to 7% improvement from the base. And in this case, the testing period was some around we have done 16 weeks, so that we can know that it is not for like 1 or 2 weeks or 3 weeks the model is performing way better. It should be across a longer time period, so that we can rely on what we are doing, and this can be deployed in production as such. So once we are comparing that for 16 weeks, so in the 16 weeks we can see some around 12% improvement as such. And then we have a metric being derived for all this calculation. For over here we have a metric called CP adherence. So CP adherence is basically, you can say, conditional probability adherence. So that means if you have more conditional probability adherence, that means, let's say, out of 100 the CP adherence is some around 90%. That means you are utilizing 90% of the law Roomba, and 10% might be the wastage. And in over here, since in case of law Roomba, the actual adherence which was there earlier before deploying model was some around 65%. So currently, after deploying this, we have moved to some around 75 to 80% of improvement. 70 to 80% is the CP adherence metric for on an overall basis. So that was the improvement, and that was a metric which basically helps us to derive all this. And the graph which you are is being showcased over here is based upon the CP adherence metric. So I'll just take you through the whole modeling methodology which we have followed in this case. If you see our whole architecture and how the model has performed and how the output is being utilized by the stakeholders, and what is a data source. So similarly, we have a data source called manufacturer number database, which is there in SQL. So we fetch the data from here. If you see the full flow diagram over here from the extreme left, this is the SQL database from where we are basically taking the required amount of data for analyzing this. Then it is being pulled to environment in SAS Viya. So and this particular job kicks off at some around 9 a.m. EST on each every Friday. So and this is basically a weekly forecast. And once this particular data is being fed into the SAS Viya, there are certain checkpoints which we have basically done on over here. So if you see, once we have pulled the data, and if we have certain that CP adherence metric, if that metric after the whole algorithm is being performed and we have achieved certain benchmark in that metric, if it is not achieved, then on that day it will fail and it will give an alert to the developer that due to some reason the metric has not been achieved. You just need to look up why it has not been done for that particular day. And if the job fails due to some connectivity issue or some discrepancy in the data, or we don't have data in that table for that day, then also it will generate an simple alert. It will send an email to each and every monitoring team, the developer team, and also the data engineering team. If the job fails, so they'll be getting alert and they'll be working on that particular part why it has failed. For that, if it is not failed and if it has already passed, then once the model has run, it will give you the output to Amazon S3 from SAS Viya. Then from SAS Viya, once the data is loaded in CSV file, from S3 it will be moved to Amazon Redshift, where we are basically utilizing the CSV file over there. And these are basically the model outputs. And from there, we are running an algorithm in SAS Viya, which basically utilize these particular tables in Amazon Redshift. From there, it basically shoot up an email to each stakeholder who stakeholders which are who are basically responsible and who are basically looking for this particular output. And all this process happens in the matter of 4 to 5 minutes max. And the mail this mail part is being shoot up some around 10 a.m. EST for each Friday. And this particular output will be utilized by the sales team and the production team for the further process in their on day-to-day businesses. So this was the whole architecture, how this model has been basically built, and how the output of this model is being consumed for each and every stakeholders, and they'll be getting an output in the CSV file over their email. I'll just showcase that also in the next slide. If you see over here, this is how an email is basically being sent. So it will be having CSV file with the names of that particular meal and the date of that. And I have just taken a screenshot of the actual output, and I have marked other thing which is not required over here. And if you can see, this is the kind of output they basically looks like. And this is how we have utilized SAS as one of our platform, where we actually uh, improved our forecast and improved our production efficiencies, which basically in terms leads to better customer satisfactions. And this in turns definitely helped us a lot, since we are scaling that to 11 mils, and the Proteus model procedure in SAS Viya is definitely a win-win for everyone, all of us, to deploy a model in a quick turnaround time, and that also links to better customer satisfaction with a more accurate forecast, which we are doing earlier. So uh, by all this, I'm going to end my presentation for today. So thank you all. And if anybody have any questions on this, this is Vishwajit. You can have my contact information over here. My email ID vishwajit.das@coachs.com. You can give me an email, instruct my email if you have questions on this. I'll happy to hear you, and I'm happy to answer it in a quick turnaround time. Thank you.